Hi, it's Physical Sciences and my name is Tijiko Kosa.
And I'm Peter Glover.
Yes, and we welcome you again. In this lesson, we are going to talk about a section of work within chemical change, and we'll be specifically talking about the rates of chemical reactions and chemical equilibrium.
Now, it's very important in this to try and get an idea, a mental picture of what's going on in reactions.
Exactly, and when we talk, for example, rate of a chemical reaction, we are specifically referring to how fast that chemical reaction takes place. And for us to understand that, we need to go deeper into the molecular level of the processes of chemical reaction in atoms and molecules.
Okay, let me just make a general point here. The term molecule is usually used in preference to atoms, or we don't talk about atoms and molecules. We just use the term molecule even if the process involves just a single atom changing in some way. So we just use the word molecule to give the general idea of this very tiny chemical species that is undergoing some change. Now, let's do a little demonstration to start giving you this picture of what we're talking about. Here is a process that we could call a unimolecular process, because it's a process involving a single molecule that is changing in some way. Now, here is an array of molecules. Now, in real life, of course, that would be billions and billions and trillions and many, many. But imagine that that is some kind of a molecule which undergoes some kind of change. Now, we're going to demonstrate a fairly slow rate of change. That one changes. That one. That one. That one. That one. You can see that this rate of change is fairly slow.
Yeah, maybe one molecule changes in 5 seconds.
Now, let's see what the difference is when it's a fast rate of reaction. Okay, that's changing. That's changing. You better help me here. This is changing. This is changing. This is changing. This is changed. So you see that the difference is the number of events
Per unit time.
in a certain amount of time. How many events take place? Now, that was a unimolecular process, and in the one case we saw slow reaction rate, in the other case we saw a quicker reaction rate. Now we're going to talk about a bimolecular process. All that means is
it's a process that involves two molecules changing.
all right, and so we're now going to have two different kinds of molecules in our array, and we'll see them here. And of course, what must happen now is that two molecules, a green molecule and a pink molecule, must come together in what we will call a successful joining, but we'll talk a bit more about that. Here is the picture. Okay, these two react. These two react. Those two react. These two. These two. These two. These two. These two. And eventually they will find their way together. And now what we've got is a whole bunch of molecules where reactions have taken place between the pink and the green. Now, what did it take for a successful reaction to happen?
Firstly, we had to have some collision happening between the molecules.
Two molecules
collide.
had to collide and stick together.
Yeah, and for that sticking together to happen, we need to have what we call the right orientation. These two molecules have to come together in a right kind of position. So for example, if you were to put your hands like that, you can't bring this one like this, then such a collision may not be effective. So when the two molecules, that one is effective, that one is not. So when that effective collision happens, we sometimes call it an effective collision, because it results in the product that we are actually expecting.
Tanika likes the word effective, I like the word successful, but they mean exactly the same. And the point is that molecules are not neat, round little figures like that. They can be a lot more complex. And in a molecule, you will find that one part of a molecule must be orientated so that it collides with a specific part of a second molecule. And unless that right orientation happens, the collision is not successful. In other words, a reaction will not have taken place. And this is all tied together in something that we call collision theory. Take a look here. Here's a short definition. For a chemical reaction to take place, there must be a successful or effective collision between the reactants.